Good afternoon, students. This is Professor Saima Khan from Technocrats Institute of Technology. Today, I am going to explain propagation mechanism I use in wireless communication. Before this lecture, we have completed all these services and the requirements for the wireless communication. Now, the next very important part which we are using in the wireless communication is the propagation mechanism used. So today we'll understand all these mechanisms. Let's start. I'm starting my slides. The very first slide shows now. These are the propagation mechanisms used in the wireless communication. It covers free space loss, reflection and transmission, diffraction, scattering by rough surfaces, and wave guiding. But before understanding all these propagation mechanisms, we have to concentrate on the concept of the free space mechanism. First, to understand this concept, let us see that we know that the free space mechanism is a mechanism in which is used to predict received signal strength at a particular location when the transmitter and receiver have a clear, unobstructed or line of sight path between them. Just for example, the satellite communication systems and the microwave line of sight radio links are the typical examples for that. When we undergo free space propagation mechanism, like other most large scale radio wave propagation models, the free space radio waves propagation model predict that the received power decays as a function of the transmitter receiver separation distance raised to some power. Okay, that is, we can say, power law function. Also, in a radio communication system, the propagation mechanism of the modulated signal is accomplished by means of transmitting antenna, the function of which is two type, or we can say the function is of twofold. The very first is to convert the electrical modulated signal into an electromagnetic field. In the capacity, the transmitting antenna act as an impedance transforming transducer, matching the impedance of the antenna to that of few spaces. And the second one is to radiate the electromagnetic energy in desired direction. So what happened at the receiver? We have a receiving antenna whose function is the opposite of that of the transmitting antenna. It converts the electromagnetic fields into an electrical signal from which the modulated signal is extracted. In addition, the receiving antenna may be required to suppress the radiation originating from the direction where it is not required or where it is not wanted. Typically, the receiver is located in the far field of the transmitting antenna, in which case, for all practical purposes, we see that the transmitting antenna as a fixed volume less emitter or point source. Okay. At this stage, it may be noted that it is fulfilled to have a reference antenna against which the performance of the transmitting and the receiving antenna can be compared. Uh, Also in practice, it is to assume that the reference antenna is an isotropic source defined as the omnidirectional antenna that radiates uniformly in all directions. So this is the general concept where we use in the propagation mechanism. Now, so as to understand the free space loss, uh, we have understand the free space law. Just go through this slide. No, this is the wait, students. Now this. So as to understand this propagation mechanism, very first I am taking this reflection mechanism, and we know that when a wave hits a smooth object that is larger than the wave itself, depending on the media, the wave may bounce in another direction. As a wave radiates from an antenna, it broadens and disperses. If portion of the waves are reflected, new wave fronts appears from the reflection points. And this is the general reflection mechanism which we very well known. And reflection may cause due to the outdoor and due to the indoor. Outdoor reflection causes due to the buildings all over the high buildings, roads, bodies of the water, earth surfaces, and even with the earth's surfaces. And the reflection which covers in the indoors are doors, walls, file cabinets, metal objects, glass, concrete, and everything which we have in our inside location. Now, everything by which our signal get reflection, and they may occur due to the indoor cause. These all comes in the indoor causes of the reflection. Now, so as to understand the mechanism of the reflection, consider this mirror. In the slide, we are able to see a mirror in which a laser beam hitting the mirror surface, and what we are able to see that that laser beam is reflects back, and this type of the reflection mechanism occurs when we when our signal transmit with the wireless communication, or when it travels several sources. So these are the impact of all reflection. By this reflection, we can understand it creates multi-path, which can degrade the strength and the quality of the received signal, as well as cause data corruption or cancels the signal. The phase of the wave will be unchanged. So reflection may occur due to the any reason, and as the number of the reflection occurs, the quality of the signal may degrade, but the phase of the wave will be remain the same. Now, next we have in the propagation mechanism, we have refraction, and refraction also propagate over the signal. Now, refraction occurs when a radio frequency signal is being banned. This typically can happen as the radio frequency signal passes through a medium with a different density, thus causes the direction of the wave to change. A change in the refraction can typically appears when dealing with long distance outdoor bridge links Refraction is measured based on the K factor, and a K factor is simply a value to represent the band that is occurring. In most of the case, when K factor is 1, that means it represents there is no banding of the signal, or we can say as signal is less propagate, or it has more line of sight communication. And when the K factor is less than 1, signal bending away from the earth. When the K factor is greater than 1, signal bending is towards the earth. And when we have the K factor as the ratio of the 4 by 3, normal atmospheric, in the normal atmospheric condition, signal slightly bending towards the earth. Signal slightly bending towards the earth. There are the various factors which causes refraction, and refraction covers all the indoor as well as the outdoor causes. And in the outdoor causes, it have water vapor, changes in air temperature, changes in air pressure, whereas indoor mechanism covers certain types of glass passing through the various materials, and everything by which refraction occur, it covers all the factors. It covers all the factors. Now if we see the impact of the refraction, we can say that in this picture I'm showing may cause lower data rates, retransmission, and lead to reduced capacity in both of the signal. We are able to see that our signals are refracted. Our signal is refracted. There are two antennas are showing. One is the transmitting antenna and the other is the receiving antenna. In the first picture, we can say that the signal from the transmitting antenna is refracted with the cool of the air, and after the refraction, the signal is finding way towards the receiving antenna. Although in this first picture, our signal is refracted, due to which maybe our data rates may lower. But in the next picture, we are able to see two antennas. One is the receiving, one is the transmitting antenna, and the other is the receiving antenna. And in that picture, our signal is refracted with the water vapors. And in this picture, we are able to see that from the transmitting antenna, the signal is away from the receiving antenna. In this case, retransmission may occur. So refraction sometimes cause retransmission and lead to reduced capacity of the signal. Now the other propagation mechanism is the diffraction. Okay, we know that diffraction is the bending and spreading around of a radio frequency signal when it counters an obstruction. The waves that encounter the object bend around the object, taking a longer and different path. The waves that do not encounter the object do not bend and maintain a shorter and the original path. So there are some causes which may lead to the diffraction, and the condition that must be met for the diffraction to occur are just consider the two causes which I have mentioned in the below. that characteristic of the obstructing object and the characteristic of the radio frequency signal. Characteristic of the obstructing object covers its shape, size, and the type of the material, whereas the characteristic of the radio frequency covers polarization, change of the phase, change of the amplitude. Also, diffraction is caused by some sort of partial blockage, such as a small hill or building that is between a transmitting radio and the receiver section. So these are the some causes of the diffraction, and number of factors are responsible for the diffraction as well as for the refraction and also for the reflection. Just see the impact of the so as to understand the impact of the diffraction. Consider this picture. In this picture, we are able to see a river in which a rock is there. Rock is there, which is found in between of the track of the flowing river. And what we see that before the rock, the river is following the path where it has to go, and when the rock comes, the signal is going the different way, diffracted. The river is the water is following the different waves, or I can say that in the position of the rock, the water is unable to flow. This is the case in certain case when our signal propagates in the wireless medium, and most of the time, some of the time, due to the high-rise building or a small, the signal may not be properly reached from the transmitting antenna to the receiver antenna. So this radio frequency shadow can occur, causing dead coverage zone or receive degraded signal. This radio shadow can occur due to any type of the buildings, high-rise buildings, maybe due to the big trees, and due to the I can say buildings, everything, anything due to which our signal may diffracted. Now, what comes in the next slide? Scattering. Scattering is also one of the major source for the propagation mechanism. And scattering occurs when a signal wave, when a signal wavelength is larger than the piece of a medium the signal is reflecting from or passing through. Again, I am saying scattering occurs when a signal wavelength is larger than the piece of a medium the signal is reflecting from or passing through. There are the various causes for this scattering. It covers passing through substance and due to the uneven surfaces. Passing through the substances covers smog, sandstorm, whereas for the uneven surfaces, it covers chain link fences, wire mesh in stucco walls, tree foliage, or rocky terrains. Generally, tree foliage we are able to see in the dense forest, like of Africa or any such places of India, where we have the dense forest, and we have some typical quality of the leaves we have seen in the dense forest. They have thick leaves, and due to the dense forest, it's hardly possible to receive even sunlight, and in these cases our signal will scatter from the forest, and also rocky terrains. And these are the some obstacles which affect our signal to reach successfully from transmitter to the receiver. just try to understand the impact of the scattering from this diagram. Now this is a mirror ball. This is a mirror ball in which, with the help of flashlight, if we on flashlight and it directly falls on the mirror ball, what we see that we have different signals scattering. We are able to see different signals scattered from each mirror balls, and number of we are able to see number of signal. And in that case, this is hardly to recognize that when these number of signals scattered from such type of the materials, and after leaving this mirror ball, they even again diffracted, reflected and refracted from the indoor and the outdoor materials available and the sources. So what we able to say that the radio frequency encounters some types of uneven surface and is reflected into multiple directions. The main signal dissipates into multiple reflected signal, causing substantial signal downgrade and may cause loss of the received signal. So till to this, in every type of the propagation mechanism, either it is reflection, refraction, diffraction, and the scattering, when the numbers of all these factors are increases, they automatically causes loss of the received signal, and also our signal quality degrades. Like this is the reason, and when we consider ideal case for the wireless communication, we considered only the line of sight propagation, in which there is no obstacle between the transmitter and the receiving antenna. Now next, a very important part is the free space loss. Is the free space loss, in which we can see that free space loss represents the amount of energy that a given radio wave losses at its travels through the air away from its source. Understanding the free space loss will help us understand how far a Wi-Fi signal can go. It is also widely used by Wi-Fi survey tool to predict Wi-Fi signal propagation. So all these factors will help us to understand the free space loss. Also, I just want to share one thing, that in reality, an isotropic antenna does not exist, and all antenna have some directivity associated with them. Still, the isotropic antenna is a reference to which other antennas are compared, and it is useful for explaining the fundamentals. So why I telling this you? Because in every type of the propagation mechanism, we have to treat with the transmitting antenna as well as the receiving antenna. So in now connecting with the again free space loss, it is sometimes that we can calculate by applying this mathematical formula for calculating the free space loss. We can understand this. We will take this mathematical expression, okay, which is equals to the 20 log 10 d plus 20 log to the base 10 f plus 92.45 where d is the distance between the transmitter and the receiver in kilometers, and f is the frequency in the megahertz. So this is the mathematical expression which we are using to explain this free space loss. And this is the with this formula we can easily calculate the free space loss mechanism. Now what we have next? Now free space loss is not specific to Wi-Fi waves. It can be applied to any other waves using other frequencies. Also in our Wi-Fi environments, uh, uh, free space loss refers to the amount of power. Free space power loss refers to the amount of power a Wi-Fi signal losses as it travels away from the transmitter. It can be an AP or a station, and this loss is relative to two main components, obviously frequency and the distance, as we already have these two terms in our formula also. So these are the two factors responsible for the free space power loss. Now what comes next? In the next slide, we have the wave guiding mechanism. And wave guiding is a special form of transmission line. Is a special form of the transmission line, consists of a hollow metal tube. The tube wall provides distributed inductance, while the empty space between the tube walls provides distributed capacitance. Waveguides are practically only for the signal of extremely high frequency, whereas the wavelength approaches the cross-sectional dimension of the waveguide. Below such frequencies, waveguides are useless as an electrical transmission, useless as electrical transmission lines. So these are the various factors which are responsible for the propagation mechanism. So as to conclude this, if I take all the indoor propagation models or the factors, I can say the mobile to mobile radio communication has to be analyzed with respect to the indoor mechanism, as we give importance to the outdoor mechanism propagation setup. The indoor propagation is also influenced by the same type of the mechanism as that of the outdoor propagation. These mechanisms are, we know already that reflection, diffraction, and scattering. Also, it may be noted that whether the indoor building is in open or closed status, the level of the radio signal will vary greatly depending on the status. As the antenna mounting setup also dominates the signal propagation, that is, if the antenna is mounted on ceiling, then the mobile signal strength will be stronger than mounting antenna on desk with the partitioned rooms. There are the many indoor models available. They are partition laws, that is same floor in a building, partition losses between the floor in a building, also log distance path loss model, and attenuation factor models. So this indoor propagation mechanism become important with the advent of the personal communication system, and the communications between mobile to mobile was focused much more on considering indoor propagation aspects. If the system is not properly designed, there might be greater gain loss occurrence in signal propagation. The channel degrading indoor propagation may also be subdivided into two important groups known as line of sight and obstructed signals. And some of the indoor propagation models may be uh, we have discussed. And while dealing with the wireless communication, we'll have to consider all these propagation models. Whereas in the outdoor propagation models, it covers all the tall building, hilly regions, trees, other obstacles that affect the signal propagation. We know that the nature of the propagation of the radio signal varies. Radio signal varies according to the terrain structure. According to the terrain structure. So the mobile communication system efficiently depend on the structure, and depending on the structure as well as the irregular terrain counters. The terrain profile has to carefully mentioned and measured to find the path loss component in radio propagation. So all these are the factors which are responsible for the uh, loss of signal loss in using in the wireless communication as far as concerned with the propagation mechanism. So this is the end of the session in which we have completed all the methods regarding the propagation mechanism. Okay, students, thank you.